All right, just a reminder, you need to stop this video and do the problems first. So please try the problems on your own first, then come back and check your solutions. You don't need to watch the whole video solutions if you don't need to. Just skip through, see what the answers are, and if you got it wrong, then watch my explanation. Okay, so I'm assuming you've done the problems. We want to use the properties of logarithms to expand this. So I'm going to start, I see that this is a division, so I'm going to expand it into subtraction. So this is log base 7 r cubed t to the 4th, and division becomes subtraction, log base 7 of v. Now I still have a multiplication here, so I'm going to pull that apart. So log base 7 of r cubed, multiplication becomes plus log base 7 t to the 4th. And finally, I'm going to use the down and front property to drop those exponents. So we have 3 log base 7 of r plus 4 log base 7 of t minus log base 7 of v, all expanded. For number 8, we're going to pull this apart. It's division, so I'm going to make it into subtraction. So we have natural log of 7 minus natural log of 25. This answer is completely fine. Okay, this is our final solution here. This is totally fine. If you went a couple steps further and said, oh, I know that 25 is 5 squared, great, then you can bring this down in front. So natural log of 7 minus 2 natural log of 5. This is also fine, but if you stopped at the first step, that's great. You can stop there. All right, for number 9 and 10, we're going to go the opposite direction. We're going to condense this into a single logarithm. So we know subtraction is going to be division, but before I do that, I need to move these 5 and the 7 that are down in front, and I need to pop them back up. That has to be done first. So we get log base 2 of a to the 5th minus log base 2 of b to the 7th. Now I can combine the subtraction into division. Log base 2 of a to the 5th over b to the 7th. We can do the same thing with number 10. First thing I'm going to do is pop the 2 up here. So natural log of 7 squared and the natural log of 2. I'm going to go ahead and do that exponent. So natural log of 49 plus natural log of 2. And then addition becomes multiplication. So I get the natural log of 49 times 2. So natural log of 98. If you wanted to, you could check this on your calculator. You could plug in 2 natural log of 7 plus natural log of 2, and then also plug in natural log of 98. You're going to get the same decimal. All right, last two, we want to use the change of base formula to evaluate this. Remember, you can use common log or natural log. I'll use one of each. So I can't do log base 2 of 7 using the what power thing. It just doesn't work. So instead, I'm going to do log of 7 over log 2. I'm using common log for this one. Remember, the base goes on the bottom. So log 7 divided by log 2, if we pull out a calculator, that is 2.807. And for number 12, this one I'm going to use natural log. It doesn't matter. I'm going to do natural log of 3 over natural log of 5. Remember, base goes on the bottom. Put that in the calculator and we get 0.683. You can always check this if you want, okay? Because we can use the what power idea. 2 to this power should give us 7. So in your calculator, if you do 2 to the 2.807, it should be pretty close to 7. And same thing here, 5 to this power should get you something pretty close to 3. It's not going to be exact because we have some rounding error, but that's a way you can check these. Okay. So those are our properties of logarithm. We can expand things, condense things, and use change of base. We'll be using these a ton in the next couple of days to solve logarithmic equations.